Astronomy Cast, episode 264 for Monday, May 7th, 2012. The Hazards of Spaceflight. Welcome to Astronomy Cast, our weekly facts-based journey through the cosmos, where we help you understand not only what we know, but how we know what we know. My name is Fraser Kane. I'm the publisher of Universe Today, and with me is Dr. Pamela Gay, a professor at Southern Illinois University, Edwardsville. Hi, Pamela. How you doing?
I'm doing well. How are you doing, Fraser?
Good. Well, I hate to sound like NPR or PBS for a second here, but we need to drum up some money for the production of Astronomy Cast. So we kind of need to ask for some donations.
Please.
Please. So as you know, Pamela and I don't make any money. We do this purely volunteer basis. But we do pay for transcripts. We pay for editing of the show. We have the hosting of the show and other cool educational outreach programs that we're trying to do as well. So your donations make all of this in any way possible. And so if you can see it in your heart to kick us a couple of bucks, that will help us pay for all of these expenses. Now, where can people go if they want to donate?
So if you want to donate, the easiest thing that you can do is go to astronomycast.com or .org. They both work. And there's a support the show button and a donate button, both right there. Look at the page. They're just waiting for you to click. And donations go through SIUE, so they are all tax deductible. Now you can also donate through Astrosphere New Media. That will then go to support the general things. There's a friendly guy named Joe who does our day-to-day management of things. So go through either one. They're both tax deductible here in the United States, and we just need your help making ends meet. So every time you hear us in these live recordings apologize to Preston, well, we need to feed Preston. Yeah. So please help us feed Preston. We like
Perfect. And once again, we're recording this episode of Astronomy Cast as a live Google Plus Hangout. So if you ever want to join us and watch us record the show live, we do this every Monday at noon. Although we're a little late today, but Mondays at noon on Google+. And so if you circle me, circle Pamela, you can see when we're recording the show. And that is on Google+. And we stick around, we answer questions from the fans. It's a lot of fun. So if you ever want to sort of take your love of Astronomy Cast to the next notch, you come watch us record live. Totally free. All right, cool. Well, let's get on with the show then. So we hold all these romantic notions about humans exploring the solar system, turning humanity into a true spacefaring race. But the cold, hard reality is that space, really the entire universe, is trying to kill you. Any humans venturing out into space will face all kinds of hazards. Only death will be certain. So this is this constant argument that people always have. You know, should we send humans? Should we send robots? The robot camp has some really persuasive arguments about the fact that robots should go.
Yeah, robots, you don't need to feed them, you don't need to water them, you don't need to oxygenate them. You have to keep them kind of warm, but really they're okay with being somewhat frozen now and then.
So let's take a look at, you know, if we take a human being and we try to put them out into space, how will they die? And then what are the ways that we can try to...
That's such a broad question. So just the entire process is possibility of death after possibility of death. So you start off with, you're on the launch pad, you're getting ready to take off, and your rocket can explode. Now that will also do bad things to a robot, but that's the first hazard that you have to deal with, is just getting off the ground.
And this isn't a theoretical problem. I mean, rockets explode all the time.
This happens. This is a reality.
In fact, every new space program is mostly just, you know, exploding rocket after exploding rocket.
Well, SpaceX did kind of better than the rest.
But did they blow any rockets up?
They had an engine malfunction while they were testing an engine, but so far they're doing pretty good. They're not in the whole collapsing multi-stages onto the launch pad.
You see that one where the rocket just takes off for a second and then just kind of goes boom, and then just kind of collapses. It's just like a tube filled with liquid that explodes, you know?
The early rocket days were not good.
Yeah.
So the first issue is you have to get off the launch pad. Once you make it off the launch pad, you then have to survive every different type of rocket has stages that are combined in different ways. With the space shuttle, you had to survive the separation of the SRBs, the separation of the external tank. Now you have to worry about the different stages coming off. You get through all of that. now you're in space where there's no air, where it's either way too cold or way too hot. Pick how you want to die. Fire or ice are both available depending on which side of the planet you're on. And I have a phone that's getting into my microphone. Sorry, I'm not sure where that came from. This is the problem with live.
I hear it.
I know. Okay, here it is. Turning off the phone. I don't know why it's making this god-awful noise. I'm hoping it's my own phone that's doing it. Because if it's not my phone, I can't turn it off.
Just throw it.
I'm not going to... There it goes. Okay. Sorry. I don't know what it was trying to do.
I hear it again.
It's turned off. My phone is turned off. It's not my phone. Okay. Hopefully whatever is making the noise is now done. Okay. Sorry, everyone. This is one of the problems with live broadcasting. So once you make it into space, you're dealing with the fire and ice reality of which side of the planet are you on? Are you in shadow where it's way too cold? Are you on the sunny side where it's way too hot? So you now need thermal protection. You need oxygen. You need something to scrub the carbon dioxide out of the air that you're exhaling.
So let's deal with those. I think you also, as it relates to the launch risks, you've also got the landing risks, which are whole, more physical things that could kill you. And, as we've seen, we've seen one space shuttle detonate on launch, and we've seen one space shuttle come apart on landing.
And there's been a number of capsules over the years that have been lost at various stages. Nowadays, we actually have a new hazard of what if your parachutes don't deploy? And so every skydiver's worst nightmare now becomes every space capsule flying astronaut's worst nightmare as well. The Russians tend to land on land. We at least tend to land on water, which allows you the chance to simply become a dead, smushed bug bouncing around inside of your capsule. It's either way. If you hit water at a high enough velocity, the sudden deceleration is going to do really bad things to you. So,
all right. So let's start with temperature then. You mentioned a bunch of things. So let's start with temperature. So how cold is space?
It depends on, so if you're in shadow, it can get down to just a handful, single digits of degrees Kelvin. So you're starting to hit temperatures where volatiles, oxygens, carbon dioxide all become ice. Vacuum space means they tend to become sublimated as well. So it's a bad place to be. So if you expose human flesh to this, it's gonna freeze. That's bad. Now at the same time, it'll be many hundreds of degrees on the sun side. So you're going from frozen to boiling water just by changing what side of the planet you're on.
And so it's not just having to give yourself the level of insulation that's required that you can keep yourself warm enough in the frigid temperatures of space. You've got to be able to oscillate between those two temperatures. First, super cold, then super hot,
right,
back again. So how do they deal with that?
Well, the best way to deal with it is you simply make it a giant, perfect, insulated container, because if you have a very well-insulated container, it's going to keep the contents of the container at a constant temperature. So here you simply do the multiple layers of vacuum so that you don't end up with temperature transferring in between. For spacecraft, that works. For astronaut spacesuits, you simply do multiple layers that will either reflect off the heat or simply not transfer the cold through. And then human beings are pretty good at heating up the inside of their spacesuit. So we actually have to cool off human beings inside of spacesuits and warm up human beings inside of spacecraft.
Right. But even if you're in the cold, do you still need to be warmed up, or is that...
Well, so if it's a really well-insulated spacesuit, the heat that you're generating is going to get trapped inside the spacesuit and not radiated out into space. So it's generally enough to do all of the insulation to protect the outside temperatures from migrating in, and then cool off the astronaut on the inside.
Right. Okay. So we've got so definitely your rocket's going to blow up. If your rocket doesn't blow up, then you're going to freeze solid in the vacuum or the cold of space. And I just about said the next one, which is the vacuum, right? The fact there's no air there.
Right, right. So, yeah, lack of air is a serious problem as well. Human beings kind of like to respirate. We require oxygen in order to keep our systems functioning. And if you expose a human being to the vacuum of space, the first thing that's going to happen is they're going to get all bruised up. The blood vessels in the eyes are going to rupture. Over time. Yeah, it's just a bad thing. And then at the same time, you're not getting oxygen into your lungs.
Well, let's deal with those separately, though, because, I mean, I think we as, you know, it's like fish at the same time, you know, fish don't think about the water that they're swimming in. We don't really think about the air that we're swimming in. But we evolved to deal with one atmosphere's worth of pressure pushing on our bodies at all times. And without that pressure, as you say, you just described a bunch of nasty things. So
right. So we have this atmospheric pressure pushing in on our skin. This is the equivalent of about 1 Newton of force per square meter. So if you imagine the amount of force needed to lift a kilogram rock, that amount of force is pushing on your skin all the time. And it's just the air around us that's pushing in on us at that 1 Newton per square meter. And with that, actually, did I just screw that number up? Hold on.
So
sorry, this may be one of those days that I lie and then we re-record. 1 Pascal is a Newton per square meter. There's 10 to the 5 pascals. Hold on.
Look at this, everyone. She's doing math.
I'm sorry. 1 atmosphere is 10,000 newtons per square meter, which is very different.
You want to take another crack at that?
Yeah, we kind of need to. Actually, that's 100. It's 10 to the 5. That is 100,000. Okay. Okay, so sorry.
So I just mentioned 1 Newton is 1 centimeter squared. That
doesn't help. It was what was 1 atmosphere that foiled me completely. I went to 1 Pascal instead of 1 atmosphere. Anyways,
are you ready?
Continuing the recording, fixing things.
Okay.
So here on the surface of the Earth, we constantly have this pressure bearing down on our skin. We call it 1 atmosphere. It's the equivalent of 10,000 newtons per square meter. Sorry, 100,000 newtons per square meter of force. So a newton is the amount of force required to lift a kilogram rock. So if you think about the force needed to lift that kilogram rock, there's 10,000 times that pushing on every square meter of your skin. Now, a square meter is a whole lot, but still, that's a whole lot of force that's holding our large pocket of water that is our body together. Now, our body's pushing back. So there's this equilibrium where we're pushing out the same way it's pushing in, like a balloon in equilibrium. You remove the air that's pushing on us, and our blood starts trying to get out of our body, our fluids start trying to get out of our body, the vessels in your eye start trying to get outside of your eyeball. It's all kind of gross and reminds me of why I'm a physical scientist and not a biological scientist.
But it's strange to think about that, the fact that we actually have this outward force pushing from our body at all times that is counteracting this force of the atmosphere. You don't, as you move around in the atmosphere and as you run around or ride your bicycle or, you see dancers, and you don't think about the fact that their bodies are forcing against this enormous pressure of the atmosphere at all times.
Well, if you ever go scuba diving and you start to get to serious depths, you do feel that added pressure on your body. You feel it's harder to expand your lungs. And the limitations on scuba diving in flexible suits are partially there simply because at a certain point you can't expand your lungs and you need to be inside of a submarine or a hard-bodied something. We're limited by our ability to expand our lungs, and at the same time we have to be able to push out to prevent the atmosphere from crushing us like an empty balloon.
And so we need the gas to breathe, and we need the gas to keep us from leaking.
Exploding.
But we're not going to explode.
No, it's more like a slow leak, yeah.
Yeah, that's why I said
gross.
leaking. So just to be clear, there was that, was that Outland? I don't remember there was a movie a few years ago when someone gets
Battlestar Galactica got it right. We
always say Battlestar Galactica, but when people get it wrong, right? When they throw you out the airlock and then you detonate in space.
You don't.
No, that doesn't happen. You kind of flash freeze and leak.
Bruise
and leak and yeah.
Yeah.
Okay, so we've got there's the need of our atmosphere, and our need for both keeping us to not leak and for our so awful. I do not want to go to space. So we've got the leaking, and then we've got the need for oxygen. So that's fine, so fine. We've got a spacecraft. It's keeping us warm from the cold temperatures of space. It's providing us the atmosphere. It's giving us something to breathe, but we're still not going to survive for long. So what else?
And we've only hit orbit of the Earth at this point. The hazards get worse as you get further from the planet.
So what else then is another risk, another hazard of spaceflight?
Well, you also have to worry about radiation. So if you're in sufficiently low Earth orbit, you're still mostly getting protected by the Earth's magnetosphere. Still have to worry about X-rays and things like that would get stopped by the atmosphere. But that magnetic field does a fair job dealing with day-to-day radiation hazards.
Right. You're looking at, it's the same thing like when they fly on airplanes.
Yeah.
A lot of the year, then they have an increased risk of getting cancer from the cosmic radiation that makes it through the atmosphere. And if you're up in the space station, then you're looking at even more cosmic radiation. But you're not looking at the nasty that kill you in a couple of days. You're more looking at, like, if you're just an astronaut, you're going to increase your chances of cancer later on in life.
Yeah, they haven't so far needed to evacuate the space station because of a solar flare, for instance.
And nor would they really ever need to.
I don't say that there isn't a coronal mass ejection that won't someday cause them to evacuate, but so far they haven't had to.
Right.
But we do have to worry once we leave the Earth's magnetosphere and just go as far away as the moon. There you now have to start worrying about solar flares. And once you start hitting the middle parts between the planets, the interplanetary space, suddenly you're ready to take on the full brutal force of the sun's radiation. You're dealing with high-energy particles from the rest of the universe. It's all passing through your spacecraft unless you're somehow inside of a hollowed-out asteroid, which is a completely feasible way to travel, or unless we've figured out how to create low-energy magnetic fields to artificially protect ourselves.
So let's break down those risks specifically. So we've got the dangers of the sun, and we'll sort of deal with that radiation. So what exactly is coming at us from the sun?
Well, we have a variety of both photons that are at X-ray and gamma ray and ultraviolet if you decide to hang out without glass between you and outer space. So those are just regular, everyday, high-energy photons headed towards us. We also have to worry about cosmic rays, which are higher energy particles. They're not just photons of light, but they're actual atoms heading towards us, or electrons.
And these are coming from the sun as well?
These are coming from the sun as well.
Yeah.
And when you have a solar storm, when you have a coronal mass ejection, you can get waves of high-energy electrons heading our way. And when these things hit and slow down, all of that kinetic energy from their travel gets imparted on you. And that can be deadly. So we try and avoid getting our human selves in the way of a coronal mass ejection.
And this is one of the situations, we're not talking about let's increase your risks of cancer when you're 80. We're talking about kill you
now, please.
Now. Kill you right away. And this is one of the situations that, there was these dangers of dealing with radiation, back in Chernobyl and places like that. Everybody involved in the surrounding area had an increased risk of cancer from the radiation damage, but at the same time, you just get burned by the radiation and by the particles, and you take a lethal dose, and you're done.
Yeah.
And the sun can generate this level of activity, and astronauts can get hit by it and just be all killed.
Fried.
Yeah.
So getting your human self in the way of a coronal mass ejection is a quick way to die. So not recommended unless you have proper protection, which again, figuring out how to generate heavy-duty magnetic fields, we're not there yet.
Yeah, or being able to put an awful lot of material between you and the particles and the radiation, like your hollowed-out asteroid or just a great big shield that you hide inside.
Right. Then it becomes a matter of how do you get a spacecraft that heavy moving. Hollowing out an asteroid seems to be the best idea we've come up with so far, simply because launching all those resources from the surface of the planet is hard.
But right now, the way the astronauts deal with it, or how did the Apollo astronauts deal with it? They didn't,
They got lucky. No, the Apollo astronauts simply got lucky. They managed to be on the moon between solar flares. There was a couple of the Apollo landings that, had they simply been there a few days earlier or a few days later, they could have taken significant radiation doses. It's unclear if it would have been enough to kill them, but it definitely wouldn't have been good for them.
But if people are going to be there longer, they can't count on that. They're going to have to set up shelters and be ready. And when something's detected, they're going to have to get underground and wait it out. But
and this is where lava tubes are so important.
Yeah, but I mean, fortunately, we can detect these, right?
Right. Yeah. No, we do have an early warning system. The light from the coronal mass ejection luckily travels far faster than the electrons do. Sometimes it's only a few hours of warning. Sometimes it's a couple of days of warning. It all depends on the energies involved. But any warning at all is a chance to get underground as needed.
Right. And so that's the radiation just coming from the sun, but then there's radiation coming from just the rest of the universe.
Right.
The universe wants in on the let's kill people action, right?
Yeah. So the entire universe is giving off high-energy particles here and there. You have particles coming from supernova remnants. You have particles coming from cataclysmic variable stars. You have high-energy particles coming in a little bit
there are
from here
particles coming from things that astronomers haven't been able to figure out where they're coming from yet. They have so much energy. They are theoretically impossible, and yet they're coming.
So we keep detecting these high-energy cosmic rays, not always sure where they originated, and all of them represent a possibility of blasting apart your DNA.
But this is back to the increased risk of cancer when you're 80, not kill you in... Could there be a storm of particles coming from something, some supernova, some event?
As far as we know, all of the supernovae that we'd need to worry about either would point in other directions, or they're just not near enough that we need to worry. There's always the concern that there's a nearby neutron star that we haven't detected, that there's a nearby white dwarf that we haven't detected, that's calmly eating material. But this is such a low risk. This simply falls into the category of possible what-ifs.
Right, but so there isn't a range of objects out there that could generate enough radiation to, for say, kill astronauts when they're outside of the Earth's magnetic field, apart from the sun, of course, but that
with instantaneous death.
Yeah, so there's nothing out there that's going to do that.
It's much more of a Madame Curie playing with radioactive particles kind of death,
right, exactly.
Where you're guaranteeing yourself a bad end.
Okay, so we got launch risks, we've got atmosphere problems, we've got temperature problems, we've got radiation,
oxygen and carbon monoxide.
So we've got gases of the wrong type building up.
Yes. So you have to be able to scrub all the carbon monoxide out of the air. You need to be able to keep oxygen coming into the air.
So how do they deal with that? How do you deal with these gases that are building up?
Well, currently we just scrub them out using various types of charcoal filters. It's kind of like dealing with your fish tank. Human beings, fish, it's really the same when you put them in a closed environment.
Yeah.
So they use a variety of different filters to get all of the carbon dioxide scrubbed out of the air. But I mean, long term, the idea of having a central garden that is converting the carbon dioxide rather into oxygen, and plant stuffs, that's a completely reasonable idea. So
Now, can you go on scrubbing carbon dioxide forever? Like if the astronaut just kept breathing, would you be able to just keep absorbing the carbon dioxide, or are you going to run out of whatever material you need?
I think you run out of filters eventually, but plants don't have that problem so much because they just grow.
They just grow and you eat them.
Yeah.
Right. Okay, so you're building up. But I guess more specifically, I guess you're getting waste building up. So
Well, yeah, that luckily you can sort of fling out the airlock, but you still need to be able to eat now and then. So probably you want to recycle it. I know the International Space Station actually recycles liquids as well. I'm not going to go into details on that one.
But they're not throwing everything out the window on the space station. I mean, they're gathering it all up and filling up the Soyuz capsules and the Dragon, and then taking the trash out, right?
They were just burning up in the atmosphere.
Right.
So really, they weren't returning it home.
Right. There's like you're lighting your garbage on fire outside your house.
They were just using the atmosphere, and the entire planet Earth was their house.
With their house, yeah. But I guess there was no real problem with the burning it very efficiently.
Yes.
Yeah.
But ideally, in the future, you want a completely closed system where all of your liquids are getting recycled, where all of your solids are going into fertilizer, food, depending on what stage of recycling they're in. And it suddenly becomes a very careful, you can only consume so much, and what goes in has to come out.
So now the biggest problem is going to be, for long-duration spaceflight, is really the gravity.
Right. So there you run into problems with the human beings. We need gravity in order to deal with minerals in a proper way. Our bones will actually weaken over time. Decalcification of the bones, basically. And
our muscles atrophy,
And so this is where you start looking at spinning spacecraft. You start looking at spinning beds so that you have people experiencing gravity just while they're asleep. You need to do this in multiple directions to prevent the angular momentum from doing bad things to the spacecraft. You have to add all the pieces up just right, and you have to exercise, exercise, exercise.
And the exercise only offsets it a little bit. The deterioration just goes on. When you see these astronauts that are running on their treadmills and such, they're just putting off the damage that is actually happening, to their bodies. You stay up there for a year and you come back weak as a kitten.
No, And
you stay up there longer and your bones have all just turned into jelly.
Well, no one's had that happen.
Yeah. And we don't know what about living on places like the moon and stuff where you've got partial gravity? Do we know if
there's still going to be decalcification?
But will it hit some point, or is it just going to go on forever?
I don't think we have a way of knowing yet.
Yeah, we don't know yet. Someone's got to go and be willing to live in partial gravity for 5 years.
And some of the things that we're still trying to figure out is how does it affect people of different ages? We know that there's major differences between men and women where it affects women much worse.
Yeah.
So there's lots of biomedical issues still to be solved with human spaceflight.
There's the psychological problems with flying in space.
Space
madness.
Space madness, the fact that you're trapped with the same N people who you may discover you hate.
Mm-hmm.
There's always the concern that there's a lot of mental illnesses that don't emerge until people are in their 30s. There's a lot of dementias that don't emerge until people are in their 50s and 60s. And so a crew that starts out mentally sound may not stay mentally sound. And you have to figure out how to deal with all of these things on the go.
Space aliens that want to get into your tummy and explode.
Yeah, that one I'm not going to worry about.
You're not going to worry about that one? Okay.
No.
I do. Good. All right. So now I guess the one other one as well is to deal with the sort of all of the noxious chemicals and poisons and stuff that just goes into building the spacecraft and fueling it, right?
Well, so if you've ever had a new mattress, it stinks kind of funny for a couple of days. New rugs have the worst smell. These are all things that hopefully you've dealt with before you've launched your spacecraft into outer space. And we clearly need to think about not launching things that are going to give off toxic gases.
Just open up a window.
Yeah, no, you can't
Let the air out.
Unfortunately, you do have the methane coming out of the human beings. You do have the biological waste coming out of the human beings.
Yep. So we got a couple more issues here. Fire is a deadly one.
Yes. Yeah, that all you can do is prevent it. I mean, everything that ever would affect a ship at sea, a submarine, these are all the exact same issues that you have to worry about with a spacecraft. So fire is a terrible danger. Scurvy, so you have to worry about not getting the right vitamins and minerals. So you have to feed people, you have to scrub the air, you have to not set them on fire, you have to not depressurize them, you have to not irradiate them. Yeah, humans are fragile. Send the robots.
Send the robots. No, you know what? No, I am a total advocate for human space exploration. Send the robots and the humans. Just be well aware of all of the hazards of spaceflight, to which we have filled an engineer's notebook with all kinds of ideas that I'm sure at this point they're going to be dealing with all the issues. Well, that was great, Pamela. Thank you very much.
And don't forget, listeners, please donate.
Please donate.
Feed Preston.
Yeah. Feed Preston. Have you told Preston that we're not going to feed him if we don't get donations? Be aware of that.
No, I haven't told him that. I simply looked at the bank account and said,
okay. We need to feed. And Nancy, of course, who does all our show notes. And
Romaine, who does all of our transcripts.
Our transcripts and all that. So yeah, if you can provide some donations, that would be amazing. Thank you very much. All right, well, thanks, Pamela. That was great. I really appreciate it, and we will talk to you next week.
Sounds good.
Don't go anywhere, everybody.
Save.
But while you're waiting for us to save everything, feel free to write down any questions that you did. Thank you very much to the people, to Katrina for your gravity recommendation. I was going to get to it, but that definitely got in my head. And thanks to Harbles the Skeptical for mentioning all of the poisons that you'd be generating. That one didn't even occur to me, and so that was great to get that into the show. You guys make the show better. This is amazing. Yeah. I love this. Okay. Have you saved?
Yes.
I have not. I was instead thanking people.
That's okay. I'm looking on Twitter.
Okay, cool. So if you have any questions for us, for Pamela, mostly for Pamela, I know how this goes. You can post it on Google+, just on the main sort of area where the video is on Google+. You can post it on YouTube if you're watching this live on YouTube, and you can also post it on Twitter with the hashtag AstronomyCast, and we will see any questions that you have. So we finished recording. Thomas noted that spacecraft really sound like submarines without the water supply. I guess, a submarine has the water supply. They have no shortage of water.
Well, but they still have to desalinate the water, so yeah.
But is it like the opposite of a vacuum?
Yeah.
When you think about it, right? It's like all of that pressure is pushing in and wants to kill you.
Yeah.
And I guess the ocean is inside the universe, which wants to kill you. So this goes back to rule number 1 that we have for Astronomy Cast.
Yeah.
Well, you know what? I don't see any questions unless I'm missing them. I don't see anyone. Nobody has a question for Pamela about anything at all. Don't you want to know why there's, I don't know, something and not nothing? Why is there gravity, Pamela?
We don't know.
Okay.
I can't answer everything.
What is the next talk about? What have we got as our list of topics? Let me see. What did I put as my list of topics here?
Live? I said, are we going to figure this out live?
Well, yeah. We usually what usually happens is we'll throw. I'll throw a whole pile of topics at Pamela, and then she'll pick from the list. And what have I got here? Yes, what I meant. Mass. I thought we'd do a show on mass, and do a show on heat, and a show on infinity.
And I wanted to do energy if we do mass and heat.
Energy, yeah. Animals in space. We want to do coverage of SpaceX. We talked about the exploration of Venus, which was great, but we want to do the exploration of Mercury and Jupiter and Saturn. We want to talk about...
do Eddington next.
You want to do Eddington next?
Mm-hmm.
Except there was no spacecraft.
There was a failed spacecraft, so we can mention it as a footnote that there was a spacecraft that got canceled.
So we'll do one show and a tribute to the failed spacecraft.
Yes.
This
is why you don't name your spacecraft before they launch, because now that name's retired.
Is that how that works?
Mm-hmm.
Oh, right. So you call it something really weird, and then you launch it, and then you give it a proper name.
Yep.
Yeah.
So last became Fermi. And
that makes sense.
All was well with the world.
Amateur telescope making, climate change. We actually have to do a second part of our capsules episode, which I'm sure a lot of people will be remembering.
And now we're going to need a third because SpaceX is coming out.
Totally. I want to do a show on Archimedes because he did some really neat inventions and also some great... they did some astronomical calculations. We got Eddington. We just did a hazardous spaceflight. Chinese space exploration.
That one I want to give till the end of the summer because they're getting ready to do some neat stuff.
Yeah, apparently maybe the first female Chinese astronaut's going to go up in June. Astronomy software. We want to talk about the International Space Station.
These stinky spacecraft.
Well, apparently Dragon brought that new car smell in. We want to talk about astronomers, astrophysicists, and cosmologists. We want to talk about the Soviet space program, which we haven't even talked about. Abiogenesis. So, like, what are some possible...
I don't even know what that is.
Abiogenesis? That's like, where did the first life come from?
Oh, okay.
Right? So, like, did it come from chemical soup? You know, what were the different combinations, the different... You know, we've got those cool places on Earth that might, you know, did life evolve separately on Earth, or did it come from space, like panspermia, etc.?
I'm good with the panspermia part.
We already did an episode on panspermia, but yeah, the moon and the tides. So
we have a whole list of different topics.
That was just a list I generated, you know, in half an hour. So yeah. What else? Hot Jupiter. So Thomas wants to know, what about hot Jupiter? Why? Just the exploration of Jupiter. We did a whole episode on hot Jupiter, which was, Tycho Brahe. That's a good one. Did we not do Tycho Brahe?
I don't think so.
Does he not have a spacecraft?
I think I don't know. I haven't. I thought that there was an add-on to something that was Tycho.
Just doing a Google search. Tycho spacecraft.
The Tycho catalog.
Heat 1X.
Parkos.
So the Heat 1X Tycho Brahe is a rocket and spacecraft built by the Copenhagen suborbitals.
Okay.
Never even heard of that. I guess they get a whole show because we're slaves to our...
Well, and we can also bring up the Tycho catalog. So.
Yeah. Okay. I will put on. I will edit. And I will put on Tycho Brahe onto our list of topics.
Okay.
But
we're going to do Eddington, I think, on Wednesday.
You want to do Eddington next? Okay.
And we are going to try and catch up on shows. So we're going to attempt, no promises, but we're going to attempt to also record on Wednesday.
Okay. That sounds good. Here we go. Mary Roach talks about going to the bathroom in space. What advancements have we made, and do you know of any good developments? Because personal hygiene is very important to me. This is from Ulysses Adkins.
It's basically a vacuum cleaner. See, here on the planet Earth, we have this nice thing known as gravity that pulls
You told me
the
all I needed to
away.
know. You say vacuum cleaner. I understand what that is as a bathroom. Yeah.
Yeah, no, it's really disturbing how going to the bathroom without gravity is just not as good a thing. You want gravity to go to the bathroom. Or a vacuum cleaner. That's how they solved it.
Let's see. Whoa, a whole bunch of questions just hit me. Carolyn Acorna wants to know, why do some people once think that there was a planet nearer to the sun than Mercury called Vulcan?
Because there could, and so they decided they'd name it and look for it, and then when they couldn't find it, they were sad.
But wasn't there partly the fact that they couldn't properly figure out Mercury's orbit?
No, it was actually just a matter of it was possible that there was something there that we hadn't been able to detect in the glow of the sun, and where there's a possibility, there's imagination.
That's it.
Yeah.
Okay. Oh yeah, Music Lover with like 10 circles and a 1 recommends the Saturn V. That would be a good show. I'd love to do a show just on the Saturn V and really dig into the engineering of it. It's going on the list. Or just the whole Saturn program. But just that rocket, I mean, is just is the quintessential rocket, right?
Yeah.
Here we go. Someone mentioned... Oh, Charles Wagoner asked, Pamela mentioned that spacecraft would have to spin on multiple axes or there would be problems. So can you go a little deeper on that? All the spinning stations I've seen in sci-fi are like bicycle tires. So is there something...
So this is more a matter of if you have a spinning bed. So the problem that you run into is imagine you have one person has a bed that's spinning like this and they're plastered against the wall as it goes around. The spacecraft is going to want to start spinning in the opposite direction of that. So you either need to have two beds going in opposite directions to prevent the spacecraft from starting to spin as well, or a counterweight or something else. If you have your entire spacecraft rotating, that's all fine. It's when you try and spin just part of your spacecraft that you have to balance out the motion, or the entire spacecraft will eventually end up moving.
And so in the future, spacecraft will probably look like spinning. Just
Donuts.
They're going to be spinning. But you remember, everyone remembers Babylon 5, right?
I loved Babylon.
I know, and you remember the humans, they actually took that into account, and they came up with the spacecraft where the main spacecraft stuck the same, but then there was this rotating part.
And it was 0G in the center, they totally got it.
Yeah, except that, as you said, they would constantly be having to battle the desire of the whole spacecraft to just rotate, and they should have just made the whole thing rotate. But it was really cool, the way they did it, and you finally said, like, yes, somebody got the science. Matt Masters wants to know, I'm starting an astronomy course soon, and I'm having some pre-course study. Any tips for remembering all the laws and equations that there are?
No.
No.
Flashcards.
Flashcards. Ask if you can bring the equations in. Cram them onto a piece of paper, onto your one piece of paper. I got very good in university at cramming mathematical formula into my piece of paper. It was a real art form. Michael Uberty asks, are there any theories on Saturn's hexagon at the pole?
Lots of different meteorologists, I can never say that word right. Lots of different meteorologists have been trying to figure that one out. It's one of those things where it still falls into the category of ask 5 theorists and they're going to have 10 answers. Stay tuned.
That's cool. Didn't we even include that in our mystery show?
Yeah, we did.
Yeah. Yeah, so that is a mystery. Rod Mole wants to know, how fast could the human body travel in space? Is there any problem for traveling in space?
No, well, we have to be careful of how fast we accelerate.
Right.
So you don't want to accelerate more than, I think, 6 Gs, because your heart just can't get blood to your brain effectively. But that's an acceleration issue, not a how fast are you going issue. The how fast can you go issue, the only limitation is how much energy does your spacecraft have. I
remember someone did a calculation, and I hope I'm getting this right, that if you accelerate for about 1 G for a year, you'll be going close to the speed of light. Maybe it's 10% of the speed of light. Anyway, you'll be going interstellar travel speeds.
Yeah.
At a constant rate of 1 G of acceleration. And so that's kind of convenient that you would, you could be thrusting in a nice, comfortable, I don't know, building, house, and it would feel like you're under normal gravity, but the reality is that you're actually accelerating to a significant portion of the speed of light. And then you turn this house, asteroid, building around, and then decelerate at the same speed, and again, it would feel like you were just standing on the ground, and then you would land. This sounds like a Twilight Zone episode, doesn't it? They think it's small-town America, but it's really a spacecraft, and it's accelerating the whole time. Thanks, Einstein.
The Truman Show.
Yeah.
On a spacecraft.
Werner von Braun for a show. Good idea.
Yes.
Does he have a spacecraft?
I don't
Spacecraft?
think so.
It is on the list. Thank you. I hope this is not too confusing for people that I'm having like half a conversation. So what about mechanical failures? Oh, good point. We missed that. Matt Corpy recommended mechanical failures in space, and that is exactly right.
Yeah, we sort of assume that they're humans, they can fix things. They're all Scotty. It's just that.
You just go out, but yeah, but the point being that if, your Jargonatron fails, you need to go and get a replacement part.
You can't.
You can't. So.
Yeah.
Oh, Callum wants to know if we're going to do a hangout that we'll join in. We're not going to. We're just going to keep answering some questions, and then I think we'll wrap this up.
Yeah.
Seamus Byrne wants to know, are you guys going to be doing coverage for Curiosity's landing? Yes.
Yet.
We hope so. Yes, maybe.
Yeah, we don't know yet.
We'll do something.
We'll do
Why
something.
not?
We don't know what we'll do yet.
I think, let me explain the challenge. What I want to do is figure out a way that we can get a feed from NASA into the Hangout so that we can then sort of do the peanut gallery while the event is happening. And the problem with that is going to be that the people at NASA are going to be talking. So I'm going to need a way to bring that feed into the Hangout and then mute it at the appropriate time so that we can talk about things. And also we want to be able to line up some experts who are actually involved in the program, but at the same time NASA is also going to be wanting to line up all those people in the program, and so we're going to be battling for people. So I would love to do something, and we're going to be pushing boldly back into experiment land. So yes, I suspect it will suck. So just to warn you, but whatever, it'll be fun.
We've said that before, and then ended up with several thousand happy viewers. So
that's true. That's true. Yeah, our Venus transit coverage. Who knew that people wanted to listen to 6 hours of us, hanging out with telescopes and
going,
watching.
Circle.
Circle, watching the Venus slowly transit across the sun. So Jens Riggleson wants to know, I guess this was from Astronomy Cast, what if a cataclysmic variable went off in our galactic neighborhood?
Depending on where it's pointed, bright light. In general, here on the surface of the Earth, cataclysmic variables, they go off vaguely in our neighborhood on a regular basis. If there's an undiscovered one within about 10 light years, it could do some harm, but we haven't discovered any.
But would it hit that sweet spot of killing astronauts in space but not people here on Earth?
I don't know. It potentially could. There was... What we have to worry about more is neutron stars. There was the issue of the neutron star back in, I think, 2004 that was on the other side of the Milky Way's center from us, and it rearranged its magnetic field. And when it did this, it gave off such bright gamma ray radiation that it actually caused a couple of CCD cameras that were pointed in a completely different direction to get flooded with high energy light and have to be flushed out. So if something like that happened nearby, well, we wouldn't necessarily see the neutron star. We would just suddenly get bathed in radiation.
Kate McCombs, Callum's mom, suggested we could do an episode on astronomy that we could do during the day, like looking at the moon and the sun, and we recommend some radio astronomy with your television. So that's a good one. A show about where sci-fi gets it right and where it gets it wrong. I think we've done an episode about that. Yeah,
we've done that at Dragon Con. They tend to be a little bit more chaotic, but we have done that.
It is a hoot, though. Yeah. Yeah, it's kind of fun to do that at like a science fiction convention, so you get the hoots and hollers and the people in the audience making the recommendations. But we kind of do that almost once a year, actually. We'll do a where sci-fi gets it right and where it gets it wrong. But I think it's always a fun show. And I guess we always need to update. I mean, we could go at Prometheus, right?
I haven't seen it yet.
I haven't seen it either.
Clearly something we should do.
Good. Well, I think on this note, why don't we wrap up the episode? So thanks again to everybody that watched us, and thanks Pamela as always for answering all of our questions. Now, as you said, we got a little more catch up to do, so we're going to probably do another episode maybe Wednesday, surprise. And then of course we've got the weekly Science Hour on Wednesday afternoons, and we've got the weekly Space Hangout on Thursday morning at 10 Pacific, 1 Eastern. And if you missed it, last night we recorded a real calm and casual virtual star party, but actually it went really well. We had 2 deep sky telescopes going. We looked at about 10 different objects. There were no PhD astronomers, so I was the person providing the color commentary, and but it was fun. It was really nice, actually. It was really good. So you can see that over in the Universe Today feed, or if you look back through my feed.
And it should actually be up on Astrosphere Vid.
Will it? Okay.
Yeah.
Yeah, and it was good. And so, as always, if you want to join us live, we're glad to have you answer your questions, and we'll keep going. So thanks, everybody, for watching, and we'll see you next time, Pamela.
Sounds great. Bye-bye.
Bye.